So our particular problem involved a baseball being hit by a bat right above home plate, right? About 3 feet in the air. The guy threw a nice fastball. We did a good slice, right? And a thing to note is that the slicing force and gravity is included in the acceleration function, so we don't have to worry about any of that garbage, right? So we're given our generic acceleration function, right? We're starting an acceleration function, and we're given an initial velocity, right? Or v naught, so that's velocity at v0. So we kind of want to know what our actual velocity function is, so we integrate our acceleration, and we end up with a velocity function that kind of has all these constants that it pulled out to the side. That would be C1, C2, and C3. I kind of skipped the step where we took our initial velocity v0 and just solved for those constants. So those constants are all get plugged in here, right? I need to make sure to remember to I used the negative sign on the front, just kind of kept the sign the same for everything. So this is actually adding 60 instead of subtracting 60, and this is negative 32 t, right? So now that we have an actual complete velocity function, we want to integrate again to find our position function, because the whole end goal of this question is to find the maximum height of the ball. So we need the velocity function to figure out when it's not accelerating or not. Its velocity is 0 in the air, and it's kind of going to start going downward. And we also need our position function to know where it is. So integrating our complete velocity function, we end up with kind of that position function again, generic with a bunch of constants. So plugging in our initial position of the ball, which we said was 3 feet above home plate, so 0, 0, 3, kind of with the home plate being the origin. We have solved for our actual position function. So now we want to know about the height. So J and K and all these functions don't matter at all, because that's forward, backwards, left, and right. We want to up and down. So solving for v of t is equal to 0 for k, we have 0 is equal to negative 32t plus 60. You subtract 60 from both sides, then divide by negative 32. We end up with t. The t is equal to 1.875. So this is that time t when the ball is in the air and it's starting to has no velocity and starting to come down. So we know that's a maximum. So taking that time t, we plug into p of t for our z, which would be k, right? Using just our k section here, we plug it in, and doing just regular simplification in algebra, we end up with 59.25 feet. High in the air is the max height for a ball before it starts going, which, assuming the height of this room is almost 25 feet, that's about double that, which is unreasonable for the height of a baseball. So we know that our max height is 59.25 feet. And by using our position function that we have and our velocity function, now that this is complete, we could figure out when the ball lands, where it lands, how far left or right it went, any kind of, we have a complete model of the baseball and its movement. And I think that's it. Cool. Thank you.